Hi, everybody. Welcome to today's webinar on Doodle Labs Sense, our newest feature set for automatic interference avoidance for advanced robotics and connected teams. I'm Nate Lipka, Senior Marketing Manager for Doodle Labs, and today I'll be moderating a discussion on Sense amongst the Doodle Labs staff who have developed it, rolled it out to robotics manufacturers who can now automatically avoid interference, whether environmental and incidental, or the result of direct intentional signal jamming, such as electronic warfare on the front lines in Ukraine. We'll learn about what the feature set is, what it does, how it works, who is currently using it in the field, where this technology is headed, and how you can get involved and use it yourself. First, I want to take the opportunity to introduce my coworkers here on the panel. First is Amol Parikh, VP of Marketing. Welcome, Amol.
Hey, Nate.
We also have Dominic DeMarco. He's our Senior Sales Engineer. Hi, Dom.
Hi, Nate. Hi, everybody.
And last but not least, we have Aaron Doe, Senior Principal Engineer for Doodle Labs. Hi, Aaron.
Hi, everyone.
Now, before we really take a deep dive into Sense, for those who aren't familiar, just want to give a quick overview of who we are at Doodle Labs. Doodle Labs designs and produces industrial-grade wireless networking solutions. We focus on high-throughput, long-range mesh networking for robotic systems like UAVs, which we'll talk about a lot today, as well as UGVs and tactical connected ground teams. Our new Sense technology supercharges the capabilities of our Mesh Rider radios by sensing interference and automatically switching to the best performing channel or band of operation. So I think a really good primer, a really good kickoff for us is to kind of start it off with Dom, Olupia and Dom. Dom has a lot of experience with his military background, really operating in the field and in some real world conditions, dealing with interference. He also is obviously interfacing with a lot of our customers now, getting them up to speed about Sense. Hi, Dom. Maybe just to start us off with a little bit of a primer on what is interference and why does this matter?
Yeah, Nate, great question. I mean, interference or even EMI, electromagnetic interference, it's a challenging problem for RF, especially when we're talking about something that we can't see with our own eyes and that we can't troubleshoot right away. We don't know what the problem is. We have to do a lot of deep diving and troubleshooting. When you have a link, it's almost like a thread, an interference where it could be commercial or just unintentional, where Wi-Fi can be blocking out Wi-Fi and it cuts the link and you lose out all of that connectivity. And if you look on this slide over here, we kind of have this graph on the left with a spectrum analysis tool where it shows spikes in certain lanes. And you can attune spectrum to lanes on a freeway, where if you're going the same speed and the same time and you're trying to merge into an occupied lane, you're going to have a collision. And that's going to cause and affect your link in a drastic way where you're not going to be able to see anything. You're not going to be able to connect and control your autonomous system or your unmanned system. And on the right is just a perfect example of any drone flyer that has ever flown over an urban city or flown into a mission into military environment where there's intentional jamming. That video looks exactly like what you see for minutes, where it puts people in panic because they're not able to do their mission right away. So in summary, EMI is that interruption between that link, and it could be long, it could be short, but it is threatening for anybody that is trying to do their job in any environment.
Yeah, and speaking of environments, I know with your background in the military, can you just speak briefly to kind of what that interference has meant for you directly, kind of working during your own deployment?
Absolutely. I mean, being a tactical communicator for special warfare, it's something where you're riding with, elite teams that are trying to fight the bad guys or save people. And when data communications go out, it is a full-on panic. And we didn't have these real-time analytics that SDRs or Doodle Labs radios can provide to, one, analyze spectrum and make the decisions for us. And if we did have that, we wouldn't be troubleshooting for hours in the hot Iraq sun. We'd be able to get a mission up in minutes rather than hours and days. So when we're looking at that as a whole, I'm really excited for Sense and this conversation about it going forward.
Yeah, you spoke about not having some of that technology at your fingertips to be able to use. I want to loop in Amol. Amol, can you kind of shed some light on how, what was the status quo sort of prior to us introducing this technology? How have drone manufacturers and even operators and end users attempted to combat interference prior to the introduction of Sense?
Yeah, thanks. And the short answer is there wasn't a lot that could be done to combat interference. There was more that you just had to do to really work around it. Most or all data links really were all radios providing long-range data links were single band. And what that means is that you have integrated one radio that's operating in one frequency band, and that's kind of your only option. That's your only tool available to you when you actually deploy into the field. And so if there's interference, either intentional or unintentional, in the area that the drone system or unmanned system is being deployed, that's just a problem that you're going to experience that type of issues that Dom was mentioning. But you don't have a lot that you can do about that. You can change locations. You can, change basically your mission plan to account for that interference. But you didn't have a lot available to you to actually counter that interference. That being said, even with our radios, our Mesh Rider radio platform, we started at single band as well. And what we did do and what you have available is some filtering on the radios, some ability to try to exclude interference as much as possible. But that's, again, something that is, it does something to keep interference out, but it doesn't really go as far as you need it to when you have a really dynamic situation like these various missions or deployments, or trying to fly a drone into an urban area where you just don't really know what the environment is going to provide, but you want to have the ability to really deploy anywhere and kind of do anything.
Yeah, good segue into can you tell us just about Sense really, and about the Mesh Rider technology and what is the alternative that Doodle Labs has cooked up to those issues that you talked about?
Yeah, absolutely. So what you see on the screen, and I'll hold up a couple of them, are various Mesh Rider radio form factors. The two that I'm holding here, the Nano and the Mini, these are the ones that are really designed specifically for use in UAV platforms. All of our radios are intercompatible, and I alluded to how we used to have our offering in single band configurations. Our entire Mesh Rider radio platform is multi-band now. And what that really means is, picking up from Dom's analogy of traffic on a highway, you've gone from having one highway with multiple lanes to having multiple highways somehow, but multiple highways running in parallel to each other now. And, for example, our Mini OEM in the Helix configuration, it's actually one that we developed in sponsorship by DIU. It covers 1.6 gigahertz up to 2.5 gigahertz. That's 6 contiguous frequency bands. So basically 6 contiguous highways, basically. That gave a significant, advantage of deploying into the field. Global deployments, you have various, rules and regulations around what you're allowed to operate in various places. Now having multiple frequency bands in one radio that you've integrated means that you don't have to swap in a different radio to go to another place. In a mission, you might be experiencing interference on a specific band. You have more available to you, more tools in your toolkit. But still, once we went to multi-band, we still were kind of limited with that really dynamic capability, which is really what Sense is. So if you go to the next slide, really what Sense is ensuring a resilient data link through interference avoidance. That's the high level. It's interference avoidance. So as we were mentioning before, there was interference and you had to act around it. You had to navigate around it. Now you have something built into these radios that is fully taking advantage of that multi-band, multiple highways, and allowing you to now magically, if you hit traffic on one, float over to another one that could be wide open and better operating. So what that means in terms of interference and how that really works in our long-range data links, as one of these links starts to experience interference, which really degrades the link, really reduces that capability of what the whole system is designed for, the link will kind of monitor for that, and when it gets to a certain threshold, it'll actually move over to a better operating part of a single band, so to a different lane or to a different band altogether. So now just really taking full advantage of multi-band and designing around a robust dynamic link, so you don't have to kind of define your mission or what you're trying to do around these limitations that we've had in the past.
And I know we have a video queued up here. Love to hear from you. Kind of talk us through this. It's one of our partners, PDW. Their C100 platform makes use of Doodle Labs Mesh Rider radios. Congrats to PDW. They were very recently added to the Defense Innovation Unit's Blue UAS cleared list for the C100. So I'll go ahead and play this video for you.
Yeah, it's really cool. Their platform, the C100, I always tell everyone that they have to hear it to really be super impressed by it because it is so quiet. It's a defense-oriented application drone system. It can carry various payloads. And what you're seeing in this video, we went out and did a test with them. But what you're seeing here is, again, jamming is really just intentional interference caused in a data link. And so this is that degradation of the link. And what you have that ability, what they're kind of showing there, is that ability to switch over to that different channel or different band altogether, and what that allows you to do in terms of continuing your mission and actually, maintaining operationality.
That's great. I think that would be a really great time to get a little bit of information on how it really works, have a look under the hood, and understand that a bit better. So I want to bring in Aaron here, who was obviously instrumental in the development of Sense, kind of the mastermind behind this. Aaron, yeah, how does Sense work?
Yeah, thanks, Nate. So Sense is basically Doodle Labs' automatic channel selection protocol, and it works over different bands and channels. So as Amol was saying earlier, all of our newer offerings are multi-band radios, and they cover multiple bands, such as the 915 and 2.4 gigahertz ISM bands, but also federal bands between 1.3 gigahertz and 2.4 gigahertz. So since this automatic channel selection is basically used for anti-jamming and interference avoidance. So an example could be an attacker intentionally trying to break the radio link, but it could also just be a UAV which is flying over a built-up area. So built-up areas typically have, could be hundreds of access points all beaconing at the same time. So the protocol is, you can break down the protocol into three components. So the first part is the messaging system, and then we have the link monitoring, and then finally the link recovery. So the messaging system, it's actually very simple. It's based on our current central config system, and you can find more information about it in our technical library. So I won't really go into detail about that. But the next two parts are really important, the link monitoring. So for the link monitoring, we don't actually attempt to measure the interference itself. So if you look at interference, the profile of the kinds of interference that you can experience, it can vary in magnitude, it can vary in time, and even in bandwidth. So the effects can be very unpredictable, and they highly depend on the application and how you're actually running it. So for example, an intermittent high-powered pulse could have the same average power as just a quiet background hum, but their effect on a real-time video stream could actually be vastly different. And a lot of it just depends on how you're actually streaming the video. So rather than trying to detect the interference, the Sense protocol works by detecting the link conditions. And then once a certain threshold is crossed, the radios will message each other and switch to another channel. So we actually look at three key indicators. The first one is the network congestion. The next is how long it's been since a packet was received, and finally we look at the packet loss. So the last component of Sense is link recovery. So when I mentioned that once the thresholds are crossed, a message gets sent out, and then the radios switch channels. But in a jamming event, inevitably the link is going to fail, even if it's only briefly. And so this prevents the messaging system from working. And so the radios actually need a way to recover. So during the link recovery, we basically have a primary node and we have a secondary node. And the primary node periodically changes channels to one of the channels supported by the radio. And the secondary node tries to find its way back into the network. So we have a advanced Sense guide, and you can refer to that for more information. But at this point, what I'm going to do is we're going to show you a video and which demonstrates how Sense actually works. Hi, this is Aaron from Doodle Labs. In this video, I'm going to demonstrate our Sense protocol. So the video you're seeing here is actually being streamed by my drone, and it's being sent over 2 MeshWriter radios. In the top right-hand window, you can see the link stats reported by Mission Planner, and we currently have 100% link quality. And in the window below, I actually wrote a very simple script to report link statistics. So in the column on the left, I have a timestamp. Then I report the RSSI, the number of packets, the packet loss, the activity, which is a measure of the network congestion, and the frequency. So it's currently in the 915 megahertz band. So note also that the packet loss is at the link layer, and the packets actually get retried. And so at the application layer, we can still get very high link quality, even though the packet loss can be high at the radio. So let me just quickly show you the Sense setup. So currently I have defined 6 channels for Sense to use for its switching, and I'm using the 915 and 2450 megahertz band. So you can see that the video quality is good. If I look at the latency, 1, 2, 3, 4, 5, it's quite good. And what I'm going to do is I'm going to jam the signal using a software-defined radio. And when I jam it, I'm jamming it with 100% duty cycle. So what will happen is the radios will completely lose their link with one another, and they will go into link recovery mode, and they will basically start searching for each other. So let's go ahead and do that. So the video is now frozen because I'm jamming it. The link quality dropped, and now it's basically recovered. 1, 2, 3, 4, 5. And the next row on my link stats should report that it's jumped to a different frequency, which it has. It's currently 2412 megahertz. So I can do that again. I'll just go ahead and stop this and change the jammer to 2412 and start it again. So you can see that the video froze, and it will need some time to recover. 1, 2, 3, 4, 5. And you can see that it has actually recovered, and it's currently at 920 megahertz. So you can see that when the video froze, in this case the packet loss went very high, it went to 38%, and the activity went to 72%. And I think previously what we saw here, the activity jumped from 24% to 62%, and the packet loss jumped up to 38.9%. So yeah, that's a very quick demo on how Sense works, and if you want further details, you can contact one of our sales engineers. Thank you very much.
And Aaron mentioned there, you can always visit techlibrary.doodlelabs.com for all of our technical documentation around Sense and anything else. I want to shift to Dom. So we've learned a little bit more about what Sense is, what we set out to do, and kind of how it works under the hood. Can you enlighten us on who Sense really is for? Who's going to take advantage of this type of feature?
Yeah, Nate. So, I mean, first and foremost, it's currently available in all our product offerings that have recently, that Amal just showed earlier, and it's a licensable feature. And what it's being used for right now in the commercial side are urban drone applications like scanning, mapping, inspection. You know, the hot word is LiDAR. You can use these applications, and then you can have resilient links to when you have when you experience that EMI. It starts making that shift as quick as that video, as we saw in Aaron's demonstration. And in the defense side, we're looking at surveillance, reconnaissance, and even more applications going forward. So the importance of those payloads in both environments, in both industries, you're looking at that need to have resilient links. When they go down, they can come back up at a moment's notice, and that's really the highlight and the key point of Sense and why we made it.
Yeah, in a specific case study, I'd love to get more detail from you, Dom, on this, but it's from Evolve Dynamics. You see on screen here is the Sky Mantis platform, and they're making use of Sense. Can you tell us more about that?
Absolutely. Evolve is one of our favorite, companies to work with, and just because they have such a, mission to keep modern technology and utilizing everything from a resilient, quickly deployable, all-weather drone that can be tethered, so it can be up for hours, pushing data links down to the ground controller, pushing sensor information, letting people know from a 360-degree view. And it can also fly away for 45 minutes. And when it does go over territories where there could be some interference, which is most likely intentional. And wartime, it's definitely possible to get jammed almost all the time and directed and found. So how do we make that change with sense? We're going to have that resilient link that we're talking about, being able to switch at a moment's notice. We're taking that challenge away from the operator's hands and letting the radios do the heavy lifting for them. And that's going to really just add value to what Evolve's solution from their Sky Mantis already provides.
Yeah, Mike Dewhurst was kind enough to participate in our last webinar with AVSI, which was operating drones in the world's most challenging environments, and he gave some really good insight into the importance of avoiding interference in Ukraine, where they're providing Ukraine Defense Forces with drones on the front lines in high volume. So definitely go ahead and check out that webinar on our YouTube channel, Doodle Labs YouTube channel. So future forward, would love to know kind of what's next. Aaron, I'd love to ask you first. What are the plans in terms of like continuing to develop the Sense feature set going forward?
Yeah, so Sense, first off, Sense is a major development project for Doodle Labs. So we are putting a huge amount of resources into perfecting it. So just very briefly, our efforts right now are focusing on ease of setup and ease of deployment, support for more nodes, and then, of course, faster link recovery. We always want that link recovery to be as fast as it possibly can be. Yep.
And Dom, from your perspective, obviously you have experience in the field, mentioned not really having technology like this to be able to use in your former roles, but going forward, engaging with our own customer base and possible customers of Doodle Labs, what does this type of technology really unlock for folks going forward, do you think?
I think we've really just opened up that capability up. Like we're opening a new chapter of how do we make what would be considered a high cost military solution that's been available for years, right? Anti-jam solutions, to bring that into the commercial world, right? And make that an actual feasible solution. And I think what we're doing at Doodle is we're listening to the needs of our customers and the partners that we're working with going forward, and trying to take this solution and make it better every chance we get. And that's what Aaron and his team is really taking pride on, and that's what we really take pride with. So going forward, we're really looking forward. It's just the beginning with what Sense is able to do, and we're going to keep pushing those boundaries with our team at Doodle.
Yeah, Amol, Aaron mentioned that this is a very large project and a big priority for Doodle Labs, and Dom's painted a good picture of kind of what that could mean for the market going forward. Why was it such a big priority for Doodle Labs to invest in, and how do you see sort of adding this into our offerings, pushing the agenda forward going forward?
Yeah, absolutely. And just to reiterate, yeah, absolutely is a major priority of ours in terms of R&D. We put our R&D efforts, our design efforts into just overall what can provide some of the most resilient and reliable data links. From our vantage point, we see the potential and like the really exciting future that's possible with the deployment of unmanned systems, using them to be able to remove people from dangerous situations, the ability to do things more efficiently, more effectively by including robotics. But what we see is that, and this is from direct feedback with our customers as well, if those robotic systems aren't reliable or able to function the way that they're promised, then the whole future is kind of in jeopardy. And we're kind of seeing that right now, just from the point of view of not having always the most reliable network available. It's often why we're starting those conversations when people are coming to us, because they're trying to improve on that point. And so, again, we're just trying to solve that one part of it. Our customers are doing some really incredible advanced technology applications, and we're glad to support it. So we want to be able to provide platforms that can be reliable, that can be resilient, that can provide that thing that the network can be trusted, and so the robot can really be deployed to do what it was designed to do. So for us, it's always an iterative process. We take in customer feedback. We kind of see what we think is going to be beneficial. And so that's really how, we started from our initial Mesh Rider radio lineup. We were really designed just for long range data links. And, that's where we got into multiband. Once we had multiband, Sense was the natural next step there to really take full advantage of it. So that's really how we approach our R&D roadmap. And for us, this is just a step along the way, but we have a lot of exciting stuff coming out.
That's great. For more information on Sense and all of our technology, you can always visit doodlelabs.com. For that technical documentation, getting specifically into configuration of Sense, you can visit techlibrary.doodlelabs.com. And you can always visit our YouTube channel, Doodle Labs, for this and other recordings of webinars past. I'm Nate, signing off for Amol, Aaron, and Dom. Thanks for joining.
Thank you.
Thanks, everybody.